So good afternoon, everyone, and welcome to Measuring, Reporting, and Reducing Your Environmental Footprint. And my name is Catherine Cooper from the Sustainability Learning Center, and I'm joined today by Bruce Taylor, who's president of Enviro Stewards, who's going to take us through his presentation around reducing your environmental footprint. As we get started, please feel free to introduce yourself in the chat bar and tell us something about what you really hope to get out of today. That's really helpful. Maybe even give us some context around the kind of business that you're in, because that will help as well. And also, as we move through the session, please feel free to put your questions in the chat box, and I'll be monitoring that, and I'll bring them forward to Bruce as he stops to take a breath. We will hopefully also have a few minutes at the end of the session to also entertain some questions. So hopefully that will work for everyone. Just quickly to remind you a little bit about the Sustainability Learning Center. We're a learning and networking hub for sustainability focused on professional development and skill certification. And we do instructor-led programs face-to-face as well as online. These lunch and learns. We're working on skill certification with the International Society of Sustainability Professionals, Canadian Business for Social Responsibility, and the Natural Step. And we have 51 e-learning modules as well as a number of our programs that are on demand. And you can join our Sustainability Learning Network. It's on the back end of our website. And all of these webinars are posted there afterwards, so it's free to join, and you can go on there and watch any of the webinars that we've managed to do in the past. And there's quite a number of them on there now. We had an author series that we did in the fall and spring of last year with Bob Willard and Bob Dopelt and Alan Atkinson, and there's a number of others available as well. So with that, I am going to introduce Bruce. So Bruce is president of Enviro Stewards. It's an engineering firm and a certified B Corporation that helps clients increase their profits, sustain the environment, and compelling benefit society. He's a chemical engineer with 23 years of experience and in the field of pollution prevention, water efficiency, energy efficiency, lean and clean, toxic use reduction, sustainable development, and treatment process design. Now, Bruce's international development work includes construction of an orphanage in Sudan, earthquake relief in El Salvador, and cleaner production training in Laos, and establishing sustainable income generation in South Sudan. So welcome, Bruce.
Well, thanks, Catherine. Thanks, everybody, for joining us. That's great. Maybe you want to click on my next slide. So today, here's what I'd like to cover. Some general kind of introductory remarks about concepts in sustainable design. Talk a bit about greenhouse gas measurement, which Mafusa has expressed an interest in. Then talk about broadening it to other aspects of your footprint in addition to greenhouse gas, water, toxic, solid waste. And then a bit of a discussion about absolute versus intensive footprints, and then an actual approach of how do you actually go about reducing your footprint in an economically viable manner, and then some case studies. So that's the course today. Enviro Stewards, as Catherine mentioned, is a B Corporation. Many of you may not be familiar with it. It's actually another way of measuring your footprint, in a sense. You see that on the right? Well, on the left there, you see that red square, take the free assessment. If you were to click on that on B Corp's site, it would ask you a bunch of questions, maybe 100 questions in a row, and it would spit out a score, the one on the right there, in terms of your accountability and transparency, the way you treat your employees, the value of your products to consumers, your effect on the community, your effect on the environment. If you get above 80, you can apply to be certified. And so it's a third-party certification that your company itself is good for society and environment. And so it's another way of doing it. And the questions are also fascinating. So they're very detailed, in-depth type of questions, and some of them you haven't thought of before, so it helps you to just, okay. So I found it very helpful just to do that. That part's all free. If you want to be certified, they have a small fee. For our size of corporation, it's $500 a year. It depends basically on your billing. So to illustrate the way we go about it, so here's an example for the brick brewing company. And so you want to get in the center there where it's economically, environmentally, and socially viable. But you start with whatever driver the company has. So if you see they had a revenue driver. So in their case, they're trying to compete with a buck of beer. How do you do that? Well, you got to cut your expenditures. You're going to cut people, which we're not a big proponent of, or you're going to cut utilities. And so through water conservation, energy conservation, cost of conservation, which avoided the need for acid, they cut $400,000 a year out of their operating costs. So that's good from a revenue perspective, but it also happened to be good in the environmental sphere because you're not using all these resources. Then they had these bottles they weren't using. They did a Bob and Doug McKenzie 20th anniversary thing, and they were sending the bottle to a recycler. And so I said, well, once you give them to us, and we'll send them over to South Sudan, Africa for our water projects over there. Our main water projects are teaching the people how to build drinking water treatment systems, but to supplement that, we did a bottled water project where we take that water, ozonate it, bottle it, and sell it, and they sell the same bottles over and over again. So the point to get out of there is they got some free, credible recognition from the media on the social component that also happened to be good for the environment and whatnot. So you want to get to the point where you're economically, environmentally, socially beneficial, but you start with whatever driver you're at. So just some basic concepts here. So it's okay. I've got the ball now. So in terms of kind of a historic approach is kind of take resources, use them, and then throw them away, right? And there's lots of data to, a very high percentage of everything we take from the planet is wasted. And even the stuff that isn't wasted immediately, has a very short life and then ends up as waste. And so that's kind of the historic model. And then, some consequence to that model, there's less and less resources available and there's increasing demand. And so the projections aren't very nice. So folks are encouraging kind of moving to more of a ecosystem type of mentality where, the waste of one process becomes the feedstock of another. If you consider natural processes, very infrequent that you have a waste that ends up as a hazardous waste that nobody can deal with kind of thing. And so organisms work together in that form, and now industries are starting to do that now, and that'll come in later on in talking about solid waste reduction and whatnot. An example of Tim Hortons that I gave, we'll be giving later on. Just kind of a brief summary of that. Energy in natural systems, energy comes from the sun. Waste is food for somebody else. Things are closed loop; they don't end up, as a permanent waste product. There's no accumulation of the toxics in the environment. There's big diversity. And feedback loops. If something goes out of whack, and there's something else that brings it back in line. I mean, that's kind of some concepts around that. Okay. Another concept is biomimicry. So folks are moving towards, why is a butterfly's wing such beautiful colors? It's not actually because of pigment. It's actually just because of the way that the light hits it, and it refracts that light. And so similarly, octopuses and whatnot, or glue on oyster shells. Oysters can just put a little foot out there, and they can just be attached to the basically reefs, and you can't get them off, or barnacles and whatnot. So why are the glue so much better than ours? So there's kind of a field of study of kind of seeing what's how does nature do this? Because generally it does it much more efficiently than we are. Life cycle thinking is another type of thing. So, you're tracking, from your raw material extraction, your processing, your secondary processing, your distribution, the transportation, and then the effect of your product on the consumer. And so when you do a life cycle assessment, and Catherine has a whole course on just life cycle assessment, a key benefit of that is it'll show you which portion of your process there is actually your biggest contributor to the environment. Maybe it's the energy used by your product once the consumer gets the product. Maybe it's in the manufacturing, maybe it's in the material extraction. So it helps you to focus your attention where you'll do the greatest amount of good. Not that you want to address all the areas, but you might address biggest ones in a greater detail. And that's kind of life cycle. Life cycle analysis typically boils things down to greenhouse gas. It does try to do some other things for biodiversity and whatnot, kind of factor them in also, but it's particularly good for greenhouse gas. So when you are determining your greenhouse gas footprint, there's they call it scope 1, scope 2, scope 3. And so to determine your scope 1, that's anything that you're combusting yourself. So maybe it's your natural gas, maybe it's the fuel for your distribution fleet. So you're directly generating greenhouse gas by burning things. Scope 2 is indirect. So you're using electricity. The electricity itself is pretty clean at your facility. It doesn't actually generate any greenhouse gas. However, to make that greenhouse gas, Ontario or whatever jurisdiction you're in had to burn some natural gas or coal. Fortunately, they're phasing out the coal to generate that. And so there's factors that are available based on the mix in the location you are. So say for Ontario, they'll figure out how much comes from hydro, nuclear, natural gas, coal, whatnot, and then they'll give you a factor, this much tons of greenhouse gas per kilowatt hour that you consume, and that goes into that part of the footprint. And it's taking everything back to what they call CO2 equivalent, carbon dioxide equivalent. Scope 3 is it's more arbitrary, so each facility can select, say, what else do we want to include in our footprint? So for us, we include air travel, but you could also include commuting, your solid waste, your water consumption, other things like that. And so you figure out those portions of footprint. And so that's kind of your greenhouse gas footprint, and that goes into an important aspect of that is here's a facility that we're working with, and so when you look at what they're spending on resources, only a third was natural gas and 2/3 was electricity. But when you look at the effect on the greenhouse gas, because in Ontario we get a lot of our electricity from hydro and nuclear and other things that aren't generating the greenhouse gases as much, it skews it. So even though it was a third of your spend, it was 2/3 of your footprint for carbon dioxide. And so this kind of skews towards, things that you can do to save natural gas actually have a bigger bearing on your footprint than electricity for the same amount of energy. And it's because when you're making electricity, if you're burning something to make it, basically you burn it and you get about a third of that as electricity. So there's a lot of waste, say 2/3 waste doesn't turn into electricity when you burn natural gas or whatever to make the electricity. If you're at a facility that's able to use the waste heat, then you can increase your efficiency overall by using the waste heat for something else. But in general, there's good opportunities to reduce your carbon footprint by looking at what you're burning. Obviously, there's also, electrical savings are also helpful. And then there's greenhouse gas reporting type of thing. So here's a company, Chudley's, we were working with. They make pies. They're near Milton. And so they do voluntary greenhouse gas reporting under the Carbon Disclosure Project. But in a sense, it's voluntary. In another sense, it's because Walmart is asking their supply chain to do that, right? And so they're not required, but, ultimately, that's going to affect your customers, right? And so because they want to supply to Walmart, they're voluntarily reporting to this. And so now the interesting thing is by doing the steps that I'll describe later on and how to actually conserve and reduce your footprint, before they had to report to Carbon Disclosure Project and to Walmart, they already knew exactly what they could do and the associated paybacks. So then when they're setting the targets, they're not just arbitrary and say, okay, we're going to do 10%. They know in front of them, okay, if we want to do 10%, we're going to have to make this investment and we're going to get a 1.3-year payback, right? If we want to do 15%, we got to make this investment and we'll get a 2.2-year payback. So by doing the assessment first, then you're setting meaningful targets based on what you can achieve, and you know how you're going to achieve it and how long it's going to take to achieve it. So it's very good to go through the footprint reduction exercise before you do your targeting. Other aspects. So again, carbon dioxide is harmful to the planet when it's in excess concentrations because it increases the world temperature, causes all kinds of climate effects. But there's other things, breathing toxic chemicals is also bad, right? And so if you focus all of your attention on greenhouse gases to the exclusion of your other, you're not actually being very helpful. And so in a toxic example, say if you file under NPRI, the National Pollutant Release Inventory, and for your emissions, then you also are now subject to this Ontario regulation called the Toxic Reduction Act. And so you automatically have to file under this act. And under this act, you have to describe 7 different ways that you can reduce each toxic chemical that you're emitting above the threshold and cost them out to the business case for them. So implementation is voluntary, but going through the steps of figuring out what is required to implement is helpful. So here's an example. This is a company, they anodize aluminum, and so kind of like plating baths, and they use a lot of sulfuric acid. And because they use so much sulfuric acid, they were filing under NPRI. And so by putting in a sulfuric acid recycling system, which is this one here, they would be able to avoid this much hazardous waste at this cost. They'd avoid buying this much sulfuric acid at this cost, at that cost. And then they would also avoid the need to file under this NPRI every year, and avoid the need to file under this new Toxic Reduction Act. So we use that as part of the justification. By doing all these, you want to spread as broad a nest as possible of the cost that you can avoid. In that case, their payback was 3.6 years, which is relatively long. Our average payback is actually 1.0 years. But in their case, they decided to do it anyway because what's the benefit of not having your information on the internet that you're polluting at such and such a level, right? So by not having it under NPRI and not having it under TRA, which has publicly reported, there's an intangible benefit to them that they've used to justify this 3.6-year payback project. So what we like to do is we recommend don't just look at say energy or air emissions. Also look at toxics, solid waste, hazardous waste, and the benefits of doing it together. Here's an example. So this is a company, they recycle solvent for the auto sector. So Ford, Chrysler, Toyota would give them the solvent that they use from the painting shops. They distill them in this still here, and they sell it back to Ford and Chrysler and whatnot. So what happens is the stuff that doesn't distill goes down to this still bottom tank. And when we went through the plant with our meters, this was the highest source of contaminants in the whole factory. And so what's happening is they have a fan in the wall to get rid of fumes. And so it doesn't matter what kind of windows you have, what kind of insulation you have. If you have a fan blowing air out of your factory, that's where your heat's going, right? And so instead of trying to get a more efficient fan, what we did is we said, okay, it's coming from this tank here. Why don't we seal the top of that tank, vent it through a condenser, and then condense that as solvent that they're now selling with the rest of the solvent. Now it's not in the air. Now you don't even need the wall fan. So it reduces toxic, but it also reduces energy. But in that scenario, you wouldn't have reduced the energy unless you also address the toxics at the same time. So it's good to look at them so that you don't just, like a sack of potatoes, push in one problem and 3 other problems come out. So we call that a multifaceted approach. And then there's absolute versus intensive footprint. So say in our case, we're a member of the Regional Carbon Initiative, which is one in Waterloo, there's one in Niagara, there's other ones. So it's basically businesses kind of committing corporately that they're going to do such and such. So in our case, we have an 80% reduction target, and ours is intensity based, so that's per employee. We've already reduced it 70%, so we have to another 10% to go to reach that commitment. But that's an intensity based versus because what happens is, what if your organization sells more product? What if you have more employees? What if you need more square footage? It doesn't really make sense. So sometimes it's easier to quote in terms of tons per square foot or tons per unit of production or tons per employee. And sometimes it's helpful to do it functional. What is your business actually doing, right? So say Burco sells chemicals for the pulp and paper industry. So there's a functional component of what you're selling. So maybe it's the footprint per ton of product that your customer is making. So in our case, we do it. We want to avoid 500 tons of carbon for every ton that we use, and we do that by reducing it at our client's facility. Right? And so You can get a bit creative on how you want to go about it, but sometimes it's helpful to do a intensive one. And so, say like in Bombardier, we do it, hazardous waste per aircraft they make, just to make it so that the data doesn't go up and down unnecessarily. It tracks more with, meaningful numbers. So here's an approach. This was North York Hospital in Toronto. And so in their case, we do it per meter squared, so per square foot of floor, basically. So as the hospital grew, you didn't want to skew your numbers that way. So so between 2002 and 2006, we were able to help them reduce their energy by 30%, their water by half, hazardous waste to landfill by 90%, or to hazardous waste to 90%, solid waste by 80%. Well, how do you, and biomedical by 10%? So you can see, this is called a radar chart. It's just on your Excel spreadsheet, and it's a good way of reporting multiple things at the same time. So when you're looking at this, 100% is whatever you're using at the start, and then the yellow is where you got to. So how do you reduce the hazardous waste for a whole hospital by 90%? You look at it, okay, this is the hazardous waste for the whole hospital. Most of it was actually xylene, formaldehyde, and alcohol, ethanol. And so we put a still in the lab, distilled it, and then they use it in the same lab again. So you don't generate the waste, you don't buy it. So based on solvent purchases and hazardous waste, you're saving $25,000 a year with a 1.7-year payback, but it also happened to reduce the hazardous waste by 90% because that was their largest contributor. And then they just track each of these also. So red is getting worse. This is on an absolute basis. This is on a per square meter basis. This is, you're welcome to do it or not do it this way or not, but green is getting better, yellow is about the same kind of thing, is the way that they do it. And then they ended up getting a national award. So part of the benefit of tracking stuff like this is now you've got, you're not just improving, like many plants are improving every day anyway. You walk by, you see something, you implement a change. Hopefully you do it to such an extent that that change will stick, maybe not. But if you start tracking it, you can tell whether they're sticking, but also you've got it in a format that you can record it to encourage others. So because they had some good reporting available, they ended up getting a national award from both the Canadian Council of Ministry of Environment and the Canadian Coalition for Green Healthcare. So how do you actually go about reducing the footprint? And so what we suggest is kind of an initial assessment. How do we increase the margin? What's going to increase the margin of the facility? How do you get them implemented? And then how do you track the economic, environmental, and social benefits of what you're doing? And so we boiled down to 5 questions: who, what, why, where, when. And so just to walk through that. So you're talking about change. Change is difficult. And so one of the helpful things to do when you're doing change management is whoever's going to be affected by the change, get them involved right at the beginning. So in this case, when we start a project, we think, okay, who's going to be affected by the change? And so we need the operators from those areas, and we need hands, representatives from engineering, quality control, senior management to show it's important. We do an hour training at the beginning on what we're doing, why, and how we're doing it. That way, it's not new news. And so this here is Jackson Triggs Winery in BC. And so here's kind of an illustration of that. So we had already done some work with them to cut their waste. So this is the waste organics going down the sewer, and some engineering controls, they cut it by almost half. And their water, a good winery uses about 3 liters per liter of wine. They were already better than that when we started, but we've helped them with some engineering controls to get to here. To get here, this was procedural type changes we needed. And so we went and we got this team together, taught them what we're doing, got the best operators, and we knew which processes actually contributed the most on a procedural level. And we worked with the operators until we got something that everybody was satisfied with. Take pictures, laminate it, put it right on the work area. This is how this needs to be cleaned, and got them to train the other operators. They were able to reduce it by another half almost, and we were able to get the water down to here. So the important thing is we then built them a treatment plant, but instead of building it on this basis, we built it on this basis. And by doing that, they were able to cut the capital costs by $1.5 million for their treatment system, building it half as big. So it's always better to reduce it at first before you consider treatment. And then they were able to recover some waste heat they used an anaerobic process to destroy the remaining organics, burn them in a boiler to make waste heat. Any odors we put through a biofilter to remove odors. Kind of thing. And then this was their effluent. So after the treatment system, we cut it by this, right? But the cost is what you want to avoid there, right? And so after you get the right people involved, then what? So where's our resources being used now? This is actually the more difficult part, is where's all of our water going? Where's all our solid waste generated? Where's all our hazardous waste coming from? Where's all of our kilowatt hours used? Where's our natural gas used? And so there's a series of loggers and stuff that you can use. So we use, amp loggers are relatively inexpensive. There's flow meters. Here's like a clamp-on flow meter that goes on the pipe here. You don't have to cut the pipe. And you log the flow for the week, temperature loggers, different things like that. But also in solid waste, pick a day or a week or a couple days of your solid waste and basically sort it in a pile. The stuff that's going to landfill now, sort it. So say like at the hospital that I mentioned before, sort it, weigh it, particularly the stuff that's in there that doesn't need to be in there. So how much newspaper is in this solid waste going to landfill? How much plastic? How much recyclable material? So that you can figure out what can be diverted, but also more importantly, what can be avoided in the first place. And I'll get into that a little bit on an example in a bit. And so getting to this level of detail is helpful. So this is a amp. So this is the electricity used by an air compressor. And getting to this level of detail is what's really helpful, because what's happening is this thing is shutting off every minute. And it's running at the bottom end of its range. So it's a brand new, beautiful, top-of-the-line air compressor, variable speed. You can't buy a better compressor, but it's too big. And it's shutting off every minute. So it's going to wear itself out, and it's using twice as much energy as we ended up buying one with half to a third the size that runs all the time, draws half the amps that this one does. So getting to this level of detail is what's helpful. So So where's all of our resource going? You do that waste audits, hazardous waste. If you want to reduce natural gas, it's good to look at your thermal sources. So what's our waste heat leaving the building? Where does all this energy go? Is it going out in our water, going down the sewer? Is it going out stacks? How does it actually leave our facility? And then what could potentially use that heat? So those are the heat sinks. So we're heating up water over here. Well, the water doesn't have to be that hot. We can use what's going out of the boiler stack to heat that, or so you're kind of getting that water balance, your electricity balance, your product yield. How much product are we losing? We're losing 3% of our product. What's that cost us on surcharge? But what's it costing us to buy those ingredients? So you've got the numbers later on to do your economics. And then where? So you're going to Cradle Principle is, you've all heard it, likely the vital few, the trivial many, the 80-20 rule, where you're better off to focus your attention here than down here. So wiping out these problems all together, you get less benefit than if you get a 10 or 20% improvement in one of the bigger ones. So this might be your hazardous waste sources, your solid waste sources, your electricity demands, whatever it is. You're going to focus and prioritize, spend your attention where you can do the most good. Say like Cape Canaveral in Florida, they have a policy to always reduce the 3 largest waste streams. Once you do, 3 other ones become your 3 largest, and you just keep going. So it's just nice to do that. And so here's an example of bearing in. So these 6 spots, 1, 2, 3, 4. They were losing I guess 5 spots. There's 6 spots. They're losing product to the drain every single day. So we came up with revised procedures for these 3 spots. They have potential for large spills. So we did that just to avoid risk. So by only addressing those 6 areas, the yield of the factory went from 78% to 99.2%. So they got 20% more production without buying any more grapes. Their effluent then came into compliance, and they eliminated a surcharge of $78,000 a year. And so that's the advantage of focusing in on the biggest contributors. And then why? So why are we using water for this? You're getting back to the root cause. So what problem are we trying to solve with this? And can we solve that same problem differently? So here's a sugar mill in Florida. Originally they said, okay, we're going to double production. So we need 4 new water wells, new reverse osmosis plant, 600 gallons a day or per minute, and double our wastewater treatment. So, well, where's the water going now? Oh, don't worry about it. We're maxed out every day. So let me take a look at it. So I took a look at it. 20% of their water was going to the sugar mill for the guys who, was going to the labor camp for the guys who cut the sugar cane. The only trouble is nobody's cut the sugar cane in the last 10 years. It's all done by machine. I wandered around in the labor camp. The ground literally caved in. They had a water main break for the last 10 years, but it shows up the same on their water bill every month, so nobody notices it. So it's good to ask why. By doing that and following on, we actually saved half their water. So we ended up not drilling any more wells, not buying another RO system, and we found ways to reuse 90% of their caustic that they were cleaning with. Therefore, they saved that 90%. And we avoided the treatment plant altogether by saving half the sugar that was going down the drain. So it's good to look at the why. So why are we losing sugar at this step? Can we recover it different ways? So why is very important, and you may have to ask it several times, and you may have to ask several different people, right? You'll get different answers. Kind of root cause analysis kind of stuff. In this case, we're using water to cool a vacuum pump. Well, what purpose does the water do for us? Okay, we're removing heat. Okay, if we're only removing heat, then we can do that by getting it to a cooling tower or something else. You have to get at kind of the root cause of what this resource is doing for you, and then how do you solve that same problem differently? And then when? How much would it actually cost to do that? How much would we save? And when do we get our money back? This idea might have been in the plant for 20 years, but nobody knows this answer, so it never gets onto a capital approval request. And then how much would it actually recover? So, you're going to get 77% return on your money for the next 30 years. That's a pretty good investment. You're not going to find that in the stock market. And if you're going to sell your corporation, whoops, I guess I didn't add it on there. There's also enterprise value on that, or net present value. You're going to make $750,000 over the next 20 years that you wouldn't otherwise. And so that's the other thing is, people don't realize that saving money is the most lucrative thing you can do in your facility. If you increase sales by $10, you might get $1 or half a dollar of additional profit. If you save $10 of cost, you're going to get $10 of additional profit, right? And so it's very lucrative to do that type of work. And then another aspect of when is, very often when you're building a new facility or an expansion and stuff, people are very, very preoccupied with the total capital cost. And what happens is the total capital cost is actually only a small percentage of what you actually pay. So, there's a small design cost, there's a, construction cost, and people are trying usually to minimize these at the expense of these. So here's a plant they were relocating and to Elmira here where we are from Kitchener, and they were building their foundation, and we said, okay, why don't we do a blueprint review for you? So we looked at the blueprints. We found ways to cut the gap in half from what they were planning to do in the blueprint. And that was in time to actually get them implemented. So they were going to spend twice as much on their energy bill for the next, 20, 30 years, however long of the building, at the expense of, I think the payback was well under 2 years. I think it's a year and a half to do those retrofits. And so if you're doing it, it's better to do it right the first time. So that's another aspect of when. And then track the savings later on. If you implemented something, here's tracking before and after. Make sure that you actually get the savings and make sure that you keep them. So many meters are relatively inexpensive, especially when you're building something, like a little flow meter or something like that. Put it in so that you can see, how much water we're using for sanitation, and is that hot water? It costs even more for the hot water than it does for the water, so that you can track and keep the savings. And then here's just some case studies. So how are we doing on time? We're okay, yeah. So here's an audit by Bloom of 27 assessments at small companies in Greater Toronto area. They found that 90% of them were going to implement most of the recommendations, which would save $6 million with a $6 million investment. Excuse me. So 100% ROI. So people don't think that environmental things are, we should do some production things instead. Where else are you going to get this kind of money from? And so it's very interesting. So then there's different ways, instead of saying those projects that I just mentioned would save 2,000 tons a year hazardous waste, but that's hard to get your mind around. But they would equivalently avoid 100 tanker cars a year of hazardous waste. Now it's a bit easier to get your mind around kind of thing, or the amount of water, 685,000 cubic meters doesn't mean a whole lot, but that's like a train 100 kilometers long full of water. So, there's different ways to do it. So think of, in the energy ones, there might be, the amount of homes that could be heated or powered, or the amount of cars that you could take off the road. So try and get it in a format that people can understand. And then other, water footprint. How do you reduce your water footprint? Also, here's a Guelph project where basically we're helping them recover the water from the roof of the transit facility, and then use that for the final the buses. Now, the advantage of using rainwater is it's already distilled versus hard groundwater. So they use less soap, they don't need a spot remover, and then they can reuse that final rinse for the initial rinse, and so they can severely reduce their water flow. Here's a company that thinks these bulk transport trailers, so they had some legal bylaw type drivers initially, but they were able to get so far beyond that that they avoided these toxic chemicals. They saved $500,000 a year between the two facilities, and then they got some positive PR. They were in the, this is their effluent drop. They thought it was going to drop 16,000 months. It actually dropped 18. And then they got some positive PR. So once you implement some stuff and you track it, take a look at your newspapers and whatnot. See who wrote the articles that you like, right? And then approach them. Say, here's a potential story for you. They, may or may not pick it up, I think, but it's a good way of getting the story out there. And then they generate a responsibility report every year. So here's their footprint before and after. So again, remember how I showed you 100% is whatever they're using, in this case in 2005, and this is where they got to in 2012. And so in their case, this is per tanker car they wash, so that's an intensive measurement. And so water, they're actually using more because they're using more water to wash them longer. They've saved a bit of gas, electricity, their effluent organics, hazardous waste, and garbage 80%. So it's a good way of tracking things. So next, it also shows you where you should focus next. So, these ones are still lagging a bit, so let's focus on those. And so we're looking at reusing the final rinses there because they're hot water and they save gas for that, and you're going to save water. I think this is my final one or two case studies. This is Tim Horton. So this is the director of manufacturing. Why is he sunburned and covered in dirt and with his daughter in a mud hut in the middle of South Sudan? Well, he got there because he had a environmental driver. So putting too much sugar and whatnot down the sewer. And so the short answer would be, if we stayed over in the environmental sphere, okay, let's build you a biological treatment plant for $1 million. But instead, you do it economically, right, and environmentally viable, then by reducing the sugar loss in the first place. And then you can get some social benefits in here also, which I'll show you in a second. So even though the production increased by 2/3, the amount of water went down by 60% and BOD by 80%. So that's an absolute basis. But on a relative basis, per unit of production, it was these numbers. In terms of the economics, these are their numbers of how much they were saving. So $490,000 a year. He gave every employee a $4,000 bonus. He still had $8,000 per employee to give to Mortons. So then what they did is they took 1% of what they saved and they bought 40 of these water treatment systems in Africa. So basically, Catherine also buys them for some of the courses. So like today's course, because you guys attended, they're going to sponsor one of these biofilters in Africa. So basically, in Africa, they'll build one of these, put it in somebody's home, and it'll purify water for about 30 years. And so with 1% of the savings on that Tim Horton project, they bought that. And then it was featured in their 2011 responsibility report. This is where they're installed an existing project. This is a new project in Juba, which is the capital of South Sudan. And here's the biofilters. Then the plant manager was so interested in what we were doing, he actually came with me to verify the installation. And then it's in their 2012 report also. It just came out this about a week or two ago. So just before we take questions, so some of the conclusions of what we were talking about, it's good to think of things as a whole system, ecological. When you're looking at ecology, you look at how does one part of the system affect everything else. So the same way, take a look at your energy system as a system. It's better not to just optimize one part of the system. For example, we just did a plant where it's a pork slaughterhouse, and they put in a brand new, very high rate, 98% efficiency um, water heater, which is great, right? 98% is pretty good. However, they have waste heat all over the factory. We could have actually got 150% efficiency by using the waste heat that's going out the factory right now with the existing equipment and invest that money somewhere else. So it's good to look at the whole system, you know, your energy system, your water system, your waste and whatnot. It's good to look at it from a life cycle assessment. You know, which part of our footprint is actually biggest? Is it, you know, the materials we're using? Is it the processing at our facility? Is it our product? Can we redesign our product so it uses less energy? You know, footprints are more than just carbon. Sometimes you might want to consider doing an intensive one instead of just an absolute one. A multifaceted approach is helpful because it avoids shifting problems from one area to another, and it also builds stronger cases. So yes, from the perspective of saving water, the payback might be 3 years, but if you include the energy savings or chemical savings, you know, it might bring it down to a year, 0.2 or something like that. The conservation approach is very helpful to just systematically get down to, you know, where can we get to, and it helps you set meaningful targets. You know, if you know where you can get to and how much it's going to, what it's going to take to get there, then you can set a target that's achievable. And then it's very important to monitor, track, and report on the savings. And there's different ways to report on it. Carbon disclosure projects are a great thing for greenhouse gas emissions. So with that, maybe Catherine, we could open it up to questions.
Yeah, this is all of your examples are just amazing. So I'd like to get people to unmute themselves or put up their hand or put a question in the chat box, because you're probably sitting there going, oh my goodness, there's so much here. I think you've created a really compelling case for this. So one of my questions is for you, just to get people starting to think about this, is around data collection.
Mm-hmm.
When you go into many of these operations, do they have the data? Do you have to start from scratch? I mean, what is it you find? Because it seems like there's a whole culture of data collection that probably has to be established in order to look at your footprint and then move it towards where you need to go.
I agree. Yeah, that's the hardest part of the project is data collection. What we find is the smaller the margin that people make on their products, the more likely they are to have good data. So we did Trimac transportation, and the margins are kind of razor thin there. And so, you know, how much you're spending on water, boom. How much you're spending on energy, boom. How much you're spending on this chemical, boom, right? So it really varies by the facility, and that really drives the cost of the assessment, right? If you've already got this information, then we don't have to go and get it. And just the process of collecting the data really helps out. So we just did a plant, and it's a food processor. When we did our study, they're actually paying 3 times more on their water bills than they're actually using, right? So we put our meter next to the city water meter, and they agreed with each other, they're fine. But when we compared their own meter from the city with the meter readings on their water bills, they're off by 10 times. And so one of their meters was 10 times too high, the other one was 10 times too low. And the net effect was 3 times more water. So they're paying 3 times more for the last 2 years than they should have been. And so just the fact of collecting data often finds benefits. And it also shows you, well, how much does it cost for us to do that? You know, we're using water to just convey stuff through our, you know, plants. You know, how much is it actually costing us to do that in terms of our water bill and our sewer bill? And so data collection is very key, and it's a team type effort. And when you're installing a new piece of equipment, consider putting a meter on it. You know, it's always a challenge once something's running to put say a gas meter on it, because you've got to shut this thing down, cut open the pipe, put the meter in. But when you're building the thing, it's much easier and cheaper. If you've already got something running, there's a bunch of clamp-on type stuff that you can use. So say like these clamp-on flow meters are helpful, because you can clamp them on the pipes without disturbing production. You just continue producing and you just log it for a week and see what it's doing. But there's also even low-tech stuff like bucket and stopwatch. You know, how much does it cost for us for our sanitation? Well, get out one of your guns, put it in a 5-gallon pail, and time how long it takes to fill the pail. Now multiply that by the number of minutes that this guy uses this thing, and you got an idea of how much water he's using. you measure the temperature, you know how much energy was used to heat that water, and that'll help you get to some of your balances. But yeah, data collection is very challenging.
I see that Suzanne's posted something, and I wonder, Suzanne, if you'd be willing to unmute yourself and just, or I can unmute you for you, and just ask or make that comment. And from, you know, you're with the city of Oshawa, so what kind of, you know, when you see all of this, what kind of challenges and opportunities does it present for you as you're thinking through doing the footprint of your entire municipality?
Well, first of all, thank you. It's a very interesting presentation. I think, you know, the real driver for industry is that profit and loss, and we don't have that per se. So, you know, the dollar that you invest in savings doesn't necessarily reflect in terms of return on investment and profit. So it's a little harder to sell sometimes, but I really love the idea that you look at it from the perspective of how does one part of the system affect everything else. We've done some pretty effective, actually very successful pilot projects, but we haven't been able to get that kind of buy-in. We did something a few years ago called a Community Center Conservation Challenge, and we just taught people how to use stuff. So there was no investment at all in terms of the city infrastructure, but we involved both program staff and maintenance staff. And over the course of the summer, we saved about 600,000 kilowatt hours of electricity. And that was simply by teaching people how to use the stuff, which is so important. I mean, it doesn't matter what kind of investment that you make in these efficiencies. You really have to teach people how to use them. And the other comment that you made, Bruce, about the finding out where the water was going, I thought that was hilarious. When we did our inventory of our various electricity outlets that we had in the city, we found something like 138 buildings, but we only have 110. And these were 28 basically poles in the ground with electrical outlets on them that have been draining electricity that nobody bothered to disconnect for whatever reason. So it's really, really important to find out exactly where this stuff is going.
That's great. Thanks, Suzanne. That's very helpful. Yeah, if you attended, I think it's dollars to cents workshops, that they have a good example of that, where you're mentioning here 30% of savings from technology, 70% from people. In their statistics, they have, you know, if you just come in with technology, sometimes you're worse than you started, right? But if you come in with technology and training, you get better than either of them alone, and you're more likely.
Yeah, and I think the key there is the training isn't just for the people who are responsible for the maintenance and installation of the equipment.
Yeah, I agree. Say like that brewery I mentioned, you know, go for the first tour with the plant manager. He walks by this area. There's a red hose tucked into the sewer drain, putting hot water straight into the drain. Obviously, as a plant manager, that's alarming, right? And so he walks over, he shuts off the valve. But instead, it's better to say, why is that on in the first place? When you talk to the sanitation guy, it's on because when he comes in for a sanitation shift, he doesn't want to wait for hot water. So he just leaves it running all day long, so that when he comes in, he's got nice hot water right away. Well, if that's the issue you're trying to solve, and that's an important one, then let's do a hot water loop so that there's always hot water available, but at least you're sending it back to the boiler instead of down the drain. So you have to get at the why, and then how do you make it easier than what the person's doing now? You know, if the person's using a fire hose to push carrots into the sewer, you know, how can we make it easier to do the, you know, a shovel instead? Suzanne, maybe a question is, say the profit type of motive that isn't as good for municipal type of things. Is there any way to do it in terms of, you know, if we cut the energy 10% in this building, that we can rededicate those funds to something else, or do they just go back into some pot somewhere?
That was one of the initiatives that we originally thought about, and there's both pluses and minuses on that. If you return your energy savings to a facility for improvement, that's great, but we don't have control over the weather. So when we have one facility, it has $1 million energy bill, for example. If you have a really, really hot summer where you're having to air condition that building, then what do you do when you have a dramatic increase in your HVAC costs through no fault of your own?
Right. Yeah.
Yeah.
There's nice
So,
tools.
and
Yeah.
part of the budgeting processes from year to year, you have to ensure that you have that stable funding. Again, it's a slightly different model for municipalities than it is for corporations that have the profit and loss. But
Yeah.
I thought it was a great idea, and I was all gung-ho for it until somebody very logically said, okay, great, what happens if we have a very hot summer or a very cold winter? And how do you recoup that money?
Right. Yeah.
Yeah.
Okay. So let me answer that one then. So let's say that was the case and they did something that improves their energy 20%. Even if you have a really hot summer and they're using a lot more energy, it's still 20% less than they would have if they hadn't done the change. And so what you can do is there's programs that are very easy to use where you basically they factor in what they call the heating degree days and the cooling degree days. So basically they adjust the gas consumption based on the weather conditions.
Yeah.
And so it's a good way of comparing the baseline to what it is.
Yeah, that would be a very effective tool, I think.
I was going to ask, I don't know, Sarah, if you're able to talk. You're coming at this from a different place than Suzanne is. Suzanne's sitting there as a municipality, and you're as a kind of a service organization, trying to think about the footprint of your janitorial services. How does what we've talked about kind of apply, and where are the challenges and opportunities for you here?
Can you hear me?
Yes.
Okay. Like I said, we're still kind of focused on more waste generation at this point. We do lease our building, so there are some things that we don't have control over, but definitely awareness of our consumption and working with our property management to possibly get some sort of reporting together would be helpful. We were talking earlier, people were giving some examples of how even just digging into your data and where things are going can be enlightening. We were currently looking at our waste management practices and looking at how we can make the entire process more efficient and reduce number of pickups and things like that. And we found out that we've been billed for more containers and bins for the last 5 years than we actually had. So there's a potential credit in that regard. So same sort of thing, just digging, you kind of find out what you're actually paying for and what you're getting that way. So there's that part of how we wanted to use this for our own office, but we do offer environmental services for our clients in the janitorial field, and this kind of venturing into this other service of helping people reduce their environmental footprint was also why we wanted to participate today.
Terrific. And if you run into something really complicated, Bruce can help you.
Excellent.
Yeah, and even if you don't, your own staff can do a bit of it as far as the solid waste audit. Did you kind of follow that part? Basically, you just pick, say at the hospital, we just picked one day because they generate a lot of waste, and we just, it's a bit messy, you need gloves and whatnot, right? But just sort it all out and see what's actually ending up in the waste. And
that's actually the main component of our business is we provide waste audits for our clients.
Okay, perfect.
Yeah.
There you go. Yeah. And then the other value added to that is to move back up the chain to higher levels. So say like Tim Hortons, another one we did was their coffee roaster where they're roasting the coffee beans. And they were able to reduce their solid waste by 90% because rather than just saying, what is this waste? How do we dispose of it best? But do we need this waste in the first place? So say, the coffee packages that you see at the franchises and whatnot, a pot of coffee thing, they're hard to recycle because they're plastic and metal and whatnot. And there's 60 feet of this at the end of every roll. The question is, why is there 60 feet of unused packages at the end of every roll, right? We've changed the equipment so that we don't have that. So you're not trying to find what's the best place to put that. It's why do we even have it in the first place? And similarly, when you're roasting the coffee, you end up with this chaff, kind of a papery stuff that comes off the beans. what's the highest value? Yeah, we could burn that as fuel, but what's even better? And so looking at kind of the value to crops, there were some good nutrients in it, nitrogen, phosphorus. Similarly, the sacks that the coffee comes in. Yeah, we could burn them, but a nursery uses burlap to wrap the balls of trees, right? Or furniture. So you're trying to look at what's the highest value you can get from this waste stream. The highest value is usually putting it in a package and selling it, right? So whatever waste it was, if it's a waste ingredient, if you could change your process so you don't waste it in the first place, that's the highest value. But if you're not, what's the highest other thing we could do with it? And that's the value add that, a typical waste audit just kind of focuses on where best to put your waste. But if you take a step back and say, why is this waste in the first place? And what's the highest value end use for this waste? You get some interesting value add to the data that you get from your waste audit.
Well, it looks like we're pretty close to the end of the session today. Thank you very much, Bruce, for your time today. I think it was a really fantastic presentation. And I just wanted to say to everyone, I will be sending you a link to it so you can show it to friends, maybe in the next presentation you're making, to let them know the business reasons for doing this. And again, thank you so much, Bruce, for kind of enlightening us in this area. That's really well done. Thank you.